Okay, problem 5. Problem 5 is the integration of a function between 0 and 1. So let's say between 0 and 1, this function looks like this. All right, so first we can divide this interval into n subintervals. So we can divide it into n subintervals. All right, so here it is n minus 1 over n. So the last interval it's n over n. Okay, then right, you can see this area, it's very similar to this rectangle area. Right, these two areas, they are very similar. Then what is this rectangle area? So let's call this function fx. What is this rectangle area? This rectangle area is 1 over n, right, which is the width times height. So here you can see the height we use is at this point, right? This height is f1 over n because this function is fx, right? So it's 1 over n times f1 over n. So similarly, for this small interval, we draw this rectangle. You can see this rectangle, the area is very similar to the area under the curve, right? It's very similar to the whole area under the curve. So the area of this rectangle, it's the same. It's this part, right? It's this part, which is also 1 over n, right? Times the height. Now the height is f2 over n. Okay, times f2 over n. You can imagine all the way to the last rectangle, right? All the way to the last rectangle. This rectangle, the width is 1 over n. The height is fn over n. So the sum of all these rectangles, it's approximately the area under the curve, right? So for the area under the curve, we can use the integration to denote. So this is the actual area under the curve. Okay, this is the actual area under the curve, and this is the summation of all the rectangle areas. So when this n is large enough, which means when you divided this interval into more and more subintervals, you can see this is closer and closer to this. Okay, so here they are approximately the same, but when n is larger and larger, when n is approaching infinity, okay, the left side, okay, first for the left side we can write it in the summation form. It's a summation for let's say I from 1 to n, right? I from 1 to n, or we can use k from 1 to n. K from 1 to n, 1 over n times f k over n, right? This approximately equals the right side, the area under the curve, right? But when the left side, when n is larger and larger, when you divide this interval into more and more subintervals, you can see the left side is closer and closer to the right side. So when n is finally infinity, when n is approaching infinity, the left side equals the right side. Okay, so this is a formula we are going to use. Okay, for this question, part A, it's a summation, limit of summation, right? Summation k from 1 to n sine k pi over n. Okay, this is the first question. You can see, okay, the first question, these are the same as this, right? So the only problem is your f k over n is this sine k pi over n. So you can write this down. If your f k over n your f k over n is your sine k pi over n, right? Then what is your fx? Your fx, so let's say you call this part x, right? Which means you call this part x, right? So your fx is sine pi x. Okay, then this limit of summation equals this integration, right? This equals this integration from 0 to 1 fx. Fx is sine pi x dx. Okay, then this part, it's negative cosine pi x over pi, right? From 0 to 1. So it's negative cosine pi over pi plus cosine 0 over pi. Okay, so this part is 2 over pi. Alright, so problem part B. So again, we copy the formula. It's the limit of summation 1 over n times f k over n equals the integration of fx from 0 to 1. Okay, in part B, the left side is the limit, right? 1 over n plus 1 plus 1 over n plus 2 all the way to 1 over n plus n. So you can write this as the summation of k from 1 to n, right? 1 over n plus k. Okay, so now you need a 1 over n inside the summation, right? Here you don't have a 1 over n, so you can put a 1 over n. You can put a 1 over n here, and you multiply n over n plus k, right? And then this part, you have to write it as a function of k over n. So to write it as a function of k over n, you can just you divide by n on both sides, right? You divide by n on both sides, so the top is 1, the bottom is 1 over 1 plus k over n. So now this part is your fk over n, right? Your fk over n is 1 over 1 plus k over n. Then what is your fx? Your fx is just 1 over 1 plus x. Okay, so this part, you have got your fx, which means this limit of summation equals this integration, right? Equals the integration of fx. Okay, you've got your fx here. Okay, then this part is just lowering 1 plus x absolute value from 0 to 1. So it's lowering 2 minus lowering 1. It is lowering 2. Okay. So part C. Again, let's write down the formula first. Okay, so now the summation is 1 square plus 2 square all the way to n square. Okay, so first you can write it as limit summation, right? So now the changing variable is this, the k from 1 to n, k squared over n cubed. Right, now you want to separate 1 over n, which means this part is limit 1 over n times k over n squared. Right, so now your fk over n is k over n squared, which means your fx is x squared. Okay, so this part is exactly the integration of x squared from 0 to 1. So it is 1 over 3 x cubed from 0 to 1. Okay, which is this.